Hi students. See, in the classroom we have discussed up to 50 questions from solution. The remaining questions we are discussing here, as I told you. We are proceeding to the 51st question. Okay. 51. Solutions of A, B, C and D are respectively 0.1 molar glucose, 0.05 molar NaCl, 0.05 molar BaCl2 and 0.1 molar AlCl3. Which one of the following pair is isotonic? We have provided with the 4 different solutions and we have to find which among the following pairs are isotonic. How to recognize a pair of isotonic solution? A pair of isotonic solution will have the same particle concentration. Need not be same molecular concentration, but same particle concentration. Okay. And we know how to convert given molar or molal concentration to particle concentration. What we have to do? We have to multiply it with the Van Hoff factor. Im is the particle concentration. I into small m if molality is given. I into capital M if molarity is given. Then we can get the particle concentration that way. Okay. And here we are given all strong electrolytes, even though AlCl3 is not actually a strong electrolyte. Here it is taken to be a strong electrolyte. So for strong electrolyte, ionization is 100% and I is equal to N. What is small n? Maximum number of particles from a molecule is called small n. So for glucose, which it is a non-electrolyte, it does not ionize. So for glucose, I is equal to N is equal to 1. For NaCl, I is equal to N is equal to 2. For AlCl3, I is equal to N is equal to 4 because every molecule provides 4 ions, 1 cation and 3 anion. And again, BaCl2, I is equal to N is equal to 3 since every molecule produces 3 ions. Okay. So, all are assumed to be strong electrolytes. So, for all, I is equal to N max, maximum number of particles from molecule, I is equal to. So, particle concentration in each case is I into capital M because we are provided concentrations as molarities. So, each case, A, 0.1 molar glucose. It is a non-electrolyte. So, given concentration itself is the particle concentration. So, Im is equal to small nm is equal to 1 into 0.1 molar is equal to 0.1 molar. So, its particle concentration is also 0.1 molar. Second case, 0.05 molar NaCl. So, its Im small n I into small m is equal to small n into small m. For NaCl, I is equal to n is equal to 2. So, 2 into 0.05 giving you again 0.1 molar. So, now we know A and B are already isotonic because their particle concentrations are the same. Coming to to disprove other answers, C, 0.05 molar BaCl2. Im is equal to Nm. 3 into 0.05 because every molecule produces 3 ions. 3 into 0.05, 0.15 molar. It is having a different particle concentration. And lastly, we have D, 0.1 molar AlCl3 is equal to Im is equal to Nm 4 into 0.1 because every molecule produces 4 particles, 4 ions, so 4.4. So only these two values tally and we have only one answer here which is A and B. These two solutions are isotonic. Hope you understood that. Okay. Now we have the 52nd problem. It is like this. The boiling point of 0.1 molar potassium ferrocyanide K4FeCN6, a complex. Solution will be what? 4 options are given. I haven't copied those options. And given Kb. Kb for water is 0.52 kilogram Kelvin per mole. In the question book, in the question paper, the unit is wrongly given. You have to remember it is kilogram Kelvin per mole or Kelvin kilogram per mole. Okay, please remember that. Even that can be a question. We know delta TB is equal to I into KB into M. Elevation in boiling point delta TB is I into KB. We want to find the boiling point because it's an aqueous solution. Okay, I into KB into M. But it must be a strong electrolytes. That's why they have kept silent about the degree of ionization. So whenever in the question they keep silent about the degree of ionization, we have to take that it's a strong electrolyte. Okay, strong electrolyte. Look at the structure K4FeCN6. Evidently, it will ionize into 5 ions, 4 K plus ion and 1 ferrocyanide ion. So I is equal to N, being a strong electrolyte, must be 5. So elevation boiling point delta TB is equal to I into KB into M is equal to N into KB into M is equal to 5 into 0.52 is the elevation KB value and molality is 0.1. 0.26. So the boiling point, we have to add that elevation in boiling point to its original boiling point, which is 100 degrees Celsius. So the boiling point is 100.26 degrees Celsius, which is C in the given among the given options. C is the answer. So it's a simple question. Okay. Now the 53rd question. The boiling point of a solution of 0.11 gram of a substance in 15 gram of ether was found to be 0.1 degrees Celsius higher than that of pure solvent, not pure water, pure solvent. The molecular mass of the substance. See, in this problem, we are told that by adding a definite mass of a solute in a definite mass of solvent, the elevation in boiling point is given. Kb value of that particular solvent is also given. It is not water here. Then you are asked to find the molecular mass of that solute. It is not related to Van Hoff factor or degree of association. From the question, it is clear that the electrolyte they mentioned here must be the substance they mentioned here must be a non-electrolyte that does not ionize. In the previous problem, I made a small mistake. I told you that the given unit is wrong. Actually, the unit given there also was correct. I didn't notice they have included Celsius here. See, it can be either Kelvin kilogram per mole or degree Celsius kilogram per mole. I didn't notice C there in the previous question. They have given temperature as Celsius. So even that was correct. Degree Celsius kilogram per mole. See why? It is a difference in value is same whether it is Kelvin or in degree Celsius. What do I mean? See, suppose the temperature increases by say 20 degrees Celsius. So what is the increase if you express the same in Kelvin? 20 Kelvin. Okay. So the difference value is same whether it is in Celsius or Kelvin, and it is molar boiling point elevation constant is the increase in boiling point for 1 molar solution. So it is delta T. Kb, even Kb is delta T. So its value is independent whether we express it in Celsius or in Kelvin. So the unit is correct. 2.16 degrees Celsius kilogram per mole is also correct, like Kelvin kilogram per mole. Okay. Now coming to the answering. Elevation in boiling point delta Tb is equal to Kb into M. Here we have to elaborate the molality term as Wb divided by Wmb into 1000 by Wa. That is the elaboration for the molality term. Okay. Now we simply have to substitute. They have given elevation in boiling point is 0.1. They have given the solvent either. Its Kb value 2.16 and the mass of solute Wb added is 0.11. 1000 is already there. Wmb is unknown. Into 15 gram of Wa is 15 gram. So rearrange to get Wmb, you get it 158.4. So the answer nearest is B in the given options. So here our answer is B. Okay. 54th question, very much similar to the previous one and very straightforward question also. The boiling point of a solution obtained by dissolving 6 gram urea in 200 gram water. In this particular question, they have given Kb value as 0.56. What we have learned as 0.52. But what they have provided, we have to use, not what we know. Sometimes they may shift the value. Here they have used a different value. Here they have wrongly used the unit as degree Celsius per kilogram. That's wrong. Its unit is degree Celsius kilogram per mole. Okay. The boiling point of solution obtained. We straight away fill into the original equation. Delta TB is equal to KB into M. But M is WB into 1000 by WM into WA. 0.56 KB into 6 gram urea. 6 into 1000 by 60 is the molar mass of urea we know. 200 is the mass of solvent. You get 2.8. So the boiling point will be 100 plus 2.8 degree Celsius means 100 to 102.8 degrees Celsius. B is the answer. Okay. Fifty-fifth question. We will do only this more. 5 questions in a stretch. The delta TB for 13.44 gram CuCl2 dissolved in 1 kilogram water as solvent will be. Again, we have to find elevation in boiling point. Kb value is given 0.52. Actual value has been given. And also you are provided with the information that molecular mass of CuCl2 is 134.4. Here we have to take that copper chloride, cupric chloride, Cu2 chloride is a strong electrolyte which will ionize producing 3 ions. So Van Hoff factor I is equal to N, maximum number of particles, 3. Okay. So delta TB is equal to I into Kb into M. Is equal to N into Kb into M. Now we have to expand the term M as WB by WMB into 1000 by WA. We have provided with all the information to substitute here. N is equal to 3, Kb is equal to 0.52. Mass of solute, that is CuCl2 taken is 13.44. In the 1000 divided by molecular mass of CuCl2 has been given to be 134.4. Denominator, mass of solvent is 1000, so another 1000. Cancelling, you get a 0.156, which is very close to 0.16 degree Celsius, which is answer C in the question paper. C is your answer. Okay. We will continue in the next section. Okay. Take care.